Example 16.1, wave on a string. A student takes a 30 meters long string and attaches one end to the wall in the P6 lab. The student then holds the free end of the rope, keeping the tension constant in the rope. The student then begins to send wave down the string by moving the end of the string up and down with a frequency of 2 Hz. The maximum displacement of the end of the string is 20 centimeters. The first wave hits the lab wall 6 seconds after it was created. What is the speed of the wave? What is the period of the wave? What is the wavelength of the wave? So the given is 30 meters long string, 2 Hz frequency, and then 20 centimeter is the maximum displacement, then 6 seconds is the first wave hits. So the strategy here, letter A, the speed of the wave can be derived by dividing the distance traveled by the time. Letter B, the period of the wave is inverse of the frequency of the deriving force. And last, the wavelength can be found from the speed and the period. V equals wavelength divided by time. So the solution in letter A, the first wave traveled 30 minutes in 6 seconds. So wave is equals to 30 meters divided by 6 seconds equals 5 meter per second. Letter B, the period is equal to the inverse of the frequency. So atong gipangita ang time. So time equals length all over f, iha frequency. So equals length the I1 and then divided by 2 seconds to the power of negative 1 kay inverse man siya. So the answer is 0.50 seconds. So letter C, the wavelength is equal to the velocity times the period. So wavelength equals velocity times the time equals 5 meter per second, which is ito ang first wave, i-times siya sa 0.50 itong time period 0.50 seconds. So we derive the answer 2.50 meters. Example 16.2, characteristics of a wave. A transverse mechanical wave propagates in the positive x direction through a spring as shown in the figure 16.4 with a constant wave speed, and the medium oscillates between plus A and negative A around an equilibrium position. The graph in 16.6 shows the height of the spring versus the position, where the x-axis points in the direction of propagation. The figure shows the height of the spring versus the x position at t equals 0 seconds as a dotted line, and the wave at t equals 3 seconds as a solid line. Letter A, determine the wavelength and amplitude of the wave. Find the propagation velocity of the wave. And last, calculate the period and frequency of the wave. This is the figure 16.6, a transverse wave shown at a 2 instant of time. And this is the solution, letter A. So ang wavelength is equivalent to 8 cm and the amplitude, which is ang green arrow, which is 6 centimeters, and then the distance travel ang red. Then ang solid line, ang iyang equivalent kuan siya 3 seconds, which is ang iyang time, and then the dotted line is 0 seconds. Given t equals 0 seconds, which is the dotted line, and t equals 3 seconds equals solid line. The strategy here, letter A, the amplitude and wavelength can be determined from the graph. Letter B, since the velocity is constant, the velocity of the wave can be found by dividing the distance traveled by the wavelength by the time it took the wave to travel the distance. And letter C, the period can be found from velocity equals wavelength all over time, and the frequency from f equals L over T. So the solution, letter B, the distance traveled from time t equals 0 seconds to time t equals 3 seconds can be seen in the graph ganina. So consider the red arrow, which shows the distance the crest has moved in 3 seconds. The distance is 8 centimeter minus 2 centimeters equals 6 centimeters. So the velocity is v equals delta x over delta t equals 8. Ang delta x 8 centimeter minus 2 centimeter, and then ang delta t, which is 3 seconds minus 0 seconds. So the answer is 2 centimeter per second. Letter C, the period is t equals wavelength all over velocity. So 8 centimeter equals 2 centimeters per second equals 4 second, and the frequency is f equals 1 over t is equals to 1 over 4 seconds. Then the answer is 0.25 hertz. So the significance here, so we're going to take note that the wavelength can be found using any two successive identical points that repeat having the same height and slope. You should choose 2 points that are most convenient. The displacement can also be found using any convenient point.